Hey everyone, this week we will be doing some statistical tests. A couple people are asking me, hey, it doesn't seem like you're doing a lot with basic statistics, so they just wanted like a basic refresher or something along those lines. So I had a few people ask, hey, could you do a statistics related video with baseball data? I'm like, absolutely sure. So today we're going to be doing a t-test, and what we're going to be analyzing is comparing the group averages of spin direction. So if you saw my last video of getting that spin direction data, there is another way to get it with play-by-play data, but you won't get the, instead of getting the clock data, you'll get the degree data. So in that case, we'll get spin direction data, and we will compare if hard-throwing four-seam fastball pitchers compared to non-hard throwing four-seam fastball pitchers have a difference in spin direction in terms of degrees. So to begin, we will obviously load in our library. In the first library, and actually the only library today, will be tidyverse. So we'll load in tidyverse, give that a second or two to run, get all your stuff in, and then these will be linked to my GitHub. It's in the description below. I always leave it after all of my tweets and or LinkedIn posts, so be looking out for that to get these CSV files. So we'll say SC 2020, and just you can really say read underscore CSV if you don't prefer typing out readr. That's a habit for me, just because I'd like to use the specific read underscore CSV from the readr package. So I'll say statcast data underscore 2020 CSV. Get that CSV file, so that way we have that. And then this will also be included, though you can actually get it from a wizard himself, Bill Petty, to get that spin direction data. So I'll do the same thing. Read underscore CSV. And I'll show you again in the description. It'll be in GitHub and in the description below on how to get this play-by-play spin direction data. So I will say spin underscore direction underscore pbp.csv, since that's the name of the play-by-play file. And then we will simply just merge the two together. So SC 2020, and using under the dplyr package left join, again SC 2020 spin direction, and those 5 columns that we're mentioning here will say by equals combine, and then in quotes we'll say game pack batter pitcher pitch underscore number, and then inning. So we can get spin direction data with our statcast data. So now what we're going to do next is basically create those pitchers that threw at least 100 four-seam fastballs and classify them as a hard thrower or a non-hard thrower. So now we're going to get those averages by each pitcher that threw four-seam fastballs and then create that data set accordingly. So the way that we're going to do it is we're going to create a new data frame, call it pitchers. We're going to start by using dplyr's filter function, because I would like to keep the pitch name to be four-seam fastball. So pitch name equals four-seam fastball. So that way we only filter by four-seam fastballs. And then we will use the group by statement. So dplyr group by, we'll say pitcher name, and then continue on by saying dplyr summarize. So we're going to group by the pitcher name in this data set, so however many pitchers, and then we're going to summarize by going as such. So I'm going to create a column called n pitches, which then is n parentheses, which just means how many times that pitcher's name appear in the data set with a four-seam fastball, since we're already filtered by a four-seam fastball. Then we'll say mean fastball velo equals mean release underscore speed, which is the name of the column in that StatCast data set. So if you want to look at the StatCast data set, you can say column name's SC2020. You can see release speed is the name for pitch velocity. Of course, sometimes there may not be a pitch velocity, so na.rm equals true. And then mean spin direction, so I'll just put mean spin dir, and we'll say mean release spin direction. So that's the name of the column shown right here, release spin direction, and all within there, release spin direction. And again, remove those NAs so we can get that out of the way. All right, and then I'm going to ungroup, because now we're going to do some mutative functions. So I'm going to use mutate, and now we're going to say type equals if else mean underscore fastball velo is greater than or equal to 95. We'll consider that a hard thrower, otherwise a non-hard thrower. Now another way to say this is someone who yeets baseballs. Shout out to that specific person who I will give them the coining of that phrase and yeeting baseball. So that person I will keep anonymous unless he wants to come public about it, or she. But yeeting baseballs is a pretty fun way to say hard thrower. And then we'll continue on. Actually, we'll just keep this. So then now I'll just say mean fastball velo. I'll do a round function. So round mean fastball velo 1. So that way we can round that and make sure I have that. So round it off to 1 decimal place. And then same for spin direction. So mean spin direction round mean spin direction 1. So now we got that mutative function, and so we can get rid of all of that stuff. And then we will add the dplyr filter function to make sure that we have guys who threw at least 100 four-seam fastballs. So end pitches is greater than or equal to 100. And the last thing that I forgot before I run this is the data set itself. So don't forget that SC2020 piping operator dplyr filter. So that way we get that pitcher data. And so now we can see that 315 pitchers threw at least 100 fastballs, and you can see their mean fastball velo and then their mean spin direction, and defining whether or not they're non-hard throwers and hard throwers. So now we'll get a little bit into the t-test, and first a way to visualize it is using a box plot. That's a very common way of determining t-test. So essentially what a t-test is you're comparing means of two different groups, in this case hard throwers and non-hard throwers, to a certain variable. In this case we're asking the question, does hard throwers have a greater spin direction than non-hard throwers? Now again, spin direction is a relatively new term, but we could possibly see something in that data to indicate, hey, if you throw the ball harder, your spin direction could be this. Or maybe if you want to work towards throwing the ball harder, you should have a spin direction along these lines. And something like this will allow you to see that visually. And the simplest way to do it, since we already have tidyverse loaded, we can do pretty easily by saying ggplot, and then our data set is pitchers. Don't forget to map your aesthetics. And our x value is our type, so the non-hard thrower versus hard thrower. And then our y value is our mean spin direction. And then our fill is also type. We'll add that plus sign to indicate, hey, we're going to continue adding code. And so now we're going to do that box plot, so you can visually see those means. And then we're going to do a geom jitter. And what that basically does, it gives us a jitter plot of data points within that box plot. So first we're going to say the shape equals 16. And that's essentially, if you look it up on the interwebs, there's a ggplot like shape cheat sheet, if you will. And it just tells you like what shape you prefer it. And so that, and then our position equals position dot jitter, or position underscore jitter, and we'll say 0.02 for our width. So that way it's a little bit elongated for you to see. And then we'll add something that I've liked to add recently is theme classic. And then we will say GG title, add a nice title, and say mean spin direction by throwing type. So we'll run all this code, should appear here. So it gives you a reasonably idea of by throwing the spin direction by throwing type, and then those plots allow us to see, hey, what is the mean spin direction by certain throwers. So we can see that it's a lot smaller box plot for hard throwers than there is non-hard throwers. That means the hard throwers generally will stay around that 220 degree spin direction. Now there's some that are down here at 150 degree, whereas for non-hard throwers, it's a little bit varied here in a basic sense. So we have one non-hard thrower that has a mean spin direction under 100 degrees, and we have a non-hard thrower with a mean spin direction of about 300 degrees. Now, what does this exactly mean? Again, when we're doing a t-test, we're testing the representations of two independent samples of hard throwers versus non-hard throwers, and understanding that we're asking this question by saying, does hard throwers typically have a similar spin direction to non-hard throwers? And so in terms of statistical tests, we asked the null hypothesis and the alternative hypothesis. And in this case, the null hypothesis means that both means are equal. So that means both hard throwers and non-hard throwers have about equal spin direction. You can kind of see that it's not necessarily true, but again, we can then use the t-test to verify that. And the alternative hypothesis means that they are not equal, therefore one influences or has greater influence than the other. So we can say, like, if it were to be true by using this t-test, that spin direction has a greater influence on hard throwers than, say, non-hard throwers. So we'll get in the last part of answering that t-test question. Before I get into the t-test itself, the one line of code, I'm just going to write down little tidbits just for people to better understand this t-test and what we're trying to test for. So what we're saying is there's a null hypothesis and an alternative hypothesis. And the null hypothesis generally means, like in this case for t-test, it means the two types are equal. So we're saying the null hypothesis, again, you don't have to write this out if you don't want to. If you prefer just to see me type it out, then that's fine with you. If you want to write it out, great. But the null hypothesis is that the mean spin direction of hard throwers and non-hard throwers are equal. And the alternative hypothesis, which I'll denote as alt hypothesis, is literally the opposite of it. So the mean spin direction of each type is not equal. So when we're doing this, again, a box plot's a great way to visualize this. We can kind of already see that they're not equal. And so another way to, again, run that t-test, and it'll tell you that answer. And we'll assume a 95% confidence interval. And that, what essentially that means is that 95% of our values will lie within the true mean of our data set. So that means when we run our test, 95% of those values are within that true mean. And so this is great for determining that p-value. And what that p-value does, it means, do we reject the null hypothesis or do we fail to reject the null hypothesis? So let's say if we have a 95% confidence interval, that means our fail to reject side is 0.05, which means if we get a p-value from that t-test of 0.05 or lower, that means we reject the null hypothesis to say that the mean spin direction of hard throwers and non-hard throwers are equal. However, if it's greater than 0.05, then we fail to reject it, and there's no significant difference in the value. So we're going to run our t-test. It's pretty simple, t.test under the stats package, and then we're going to compare that mean spin direction and that tilde sign with type. And our data set is obviously pictures. So when we run this one line of code, it will spit out our answers. And so we can see our p-value is 0.002, and essentially this is like degrees of freedom, our t. And it even tells you the alternative hypothesis, the true difference in means is not equal to 0, which, again, if it's under 0.05, we we reject the null hypothesis. So we're saying that, again, and then it shows you the sample estimates. But again, going back to it, we're saying that given this t-test and the p-value of 0.002, that means we reject the null hypothesis. That means hard throwers have a greater spin direction than non-hard throwers. And we can say that if you plan to have a greater spin direction or become a hard thrower, it is possible that you need to have a spin direction around the 203 degrees area. So I hope you learned a thing or two about t-test. I will leave some resources in the description below on if you want to learn more about t-tests, different types of t-tests. This was just a real basic one sample t-test, or excuse me, 2 sample t-tests between hard throwers, non-hard throwers. But thank you so much for watching, and have a great day.